All right, we're started. Now, this is Chemistry 1, teaching about what chemistry is. Okay, and this is my first try for doing it distance-wise, so you kids can help me, all right? Now, to what is chemistry? Anybody know?
Study of
Chemistry is the study of matter, right? Anything you can see, touch, feel, anything you can smell, touch, all matter, all atoms. And actually, chemistry is the study of atoms, and atoms are very misunderstood. All right, so chemistry is the study of matter, atoms, and how they interact with each other. Okay, what? I'm all looking at the computer. Fine, just shush. Now, that's what chemistry is. Okay, it's the study of atoms, matter, and atoms are matter. We were very fortunate because we figured out that everything on Earth, water, gasoline, air, is just a combination of about 100 elements. Now, in the modern times, or even modern times, the old times, they talked about 4 elements: earth, air, fire, and they have little cartoons about them and stuff. But these are the real elements. These aren't earth, air, fire. These are really what there is. There's hydrogen, number 1. They call that atom number 1. There's helium. There's lithium, beryllium, and so on, all the way down to about 100. And you can always make a new atom, and I'll explain how you can do that later. But that's all there is. And so once you understand this, it is the language of everything, the entire earth, every rock, every bird, every feather, every beak, every scale, every piece of hair, every skin, every hamburger, every french fry is just made of some combination of these atoms. It's just like every word in the English language is made of some combination of 26 letters. You take 26 letters, you can make an infinite amount of words. You take 100 elements, you mix them together in different ratios, proportions, and you can make an infinite number of stuff. Things, wood, plastic, gas, propane, whatever. Yeah.
what is there a like each color, is that kind of like a group of stuff?
Yep, each color is kind of like a group of stuff. And I'll get to that and how the periodic table is made. But that's a great question, and it's a good observation. All right? That is chemistry. It is the study of atoms. Now, here is the one thing that was pretty neat. All right? What's an atom? Before you can understand chemistry, you have to understand what an atom is. An atom is something so incredibly small that our little brains can't even comprehend it. If you took a penny, which I should probably have a penny as a model there, going to grab me a penny. If I took a penny and I said, a penny, how many pennies would fit on Earth? How big the Earth is compared to a penny? That's about how big an atom is to a penny. The number, I used to say the grains of sand, but it's still close. Every little grain of sand to make the Earth. Every penny, how many pennies could fit in the Earth? How big the Earth is compared to a penny is how big a penny is compared to an atom. All right? That's how big. How many of these could hit little, this is a dime, but it'll work. Close enough. We're not off to a bad start. How many of these can fit in the Earth? That's how many atoms could fit in this. Atoms are so small that you can't even appreciate it. You kind of have to, it'll boggle your mind. Even at my age, I kind of am looking at something so small. I'm like, wow, that's insane. Something so small. And that's why we can never see atoms. Because an atom, we see with waves of light. And so an atom, for something to be seen, light has to bounce off it. A wave of light is like a freight train compared to a mosquito. A mosquito doesn't bounce the freight train back, so we can never see atoms because of the physical limitation. Yeah.
Is there atoms between my fingers when I put them together?
Yep. There he is. Okay, so that's what an atom, that's the size of an atom. So we're trying to get that understood. The first thing is, number one objective in this lesson, understand, appreciate, comprehend, or don't comprehend, but at least be aware of how small atoms are. There are more atoms in that little penny I had than there are sands on all the beaches on Earth. than there are grains of sand on all the beaches. Atoms are so small. There's so many. You could give each person on Earth 1,000 of those atoms, and you wouldn't even notice any of the dime being missing. Atoms are small. Atoms are tiny. They're incomprehensibly small. Our brains that evolved to understand, rabbits running or antelope or where the leopard was are not really designed to comprehend how tiny an atom is. All right? That's number one. The other thing that will blow your mind and freaks me out, is that atoms are always moving. All right? I had 2 pieces of wood. I don't know where they're at now. Oh well, I can get something else. I had 2 little pieces of wood. No, I don't want 2 bananas. Where are my pieces of wood? Very annoying. I had 2 dang pieces of wood. Oh well, I'll use these. What are these? Oh, those are the. Okay. The atoms in this are moving. Atoms are not only incomprehensibly small, but they're also incomprehensibly open space. An atom is almost all empty. We think of atoms are solid and matter is solid. 2 boards won't go through each other, and you should fall right through the seat of your pants. But atoms are all empty space, and we tend to draw an atom sort of like this. And this is everyone else. I have two schools of thought. One will say, "Oh, this is not accurate," which it's not, but it's also not a terrible thing. Nobody's that accurate with an atom. We have a little nucleus, and then we have an electron out here. I'll just make it an E, and it's whizzing around this nucleus. Okay, all of this is open space. From here to here is all empty. But it's more than that. An atom is not only incomprehensibly small, but it's incomprehensibly empty space. If a proton, and I'll have to teach you protons a little bit, was the size of a basketball, the electron would be 5 miles away. And in between this basketball and 5 miles would be nothing at all. Atoms are almost all empty. Like I said, you should fall right through your chair. Wood should pass through each other. This is 99.999% empty space. A steel rod, a ball bearing, a battleship, a tank, a car is almost all empty. And that should lead to a lot of questions. What's the question? What?
What is empty space?
Well, that's a good question. An empty space they call a vacuum is nothing. Because, for example, here, I have air, right? There's air around me. I can go like this. I can feel the air. There's billions, trillions, zillions of atoms crashing into my face. A handful of air is not empty, just because the atoms of nitrogen and oxygen are there, and we can't see them necessarily. But this is an empty space. Empty space means nothing there.
But what is nothing?
The lack of something. It's almost like what's cold, lack of heat.
Then how is something there?
Because it's space, it can be occupied with something later on. Okay? And that's where people tend to get, like, what's quiet? Quiet is lack of sound, no sound. Empty space is nothing's there. What's cold? Lack of heat. Even in the coldest winter day, it's still so hot the oxygen's boiled. All right? I want to make sure I'm not running time. I hate this little clock, which I guess it ended. So I don't know how much time I've got. I'll keep these short. Anyway, I'll just go till I finish up this. So the 2 objectives for this lesson is an atom is almost all empty space. Everything that you think of as solid matter is not. It's atoms that are almost all empty, and that atoms are incomprehensibly small, far smaller than you ever could have dreamed of. And I will get to the next thing in the next lesson, because my students told me in distance learning they like small, short videos, not one long video. So last question. What for this video? What?
So my question was, is there a difference between the atoms being closer together or farther away from each other in space versus our atmosphere?
No. Our atmosphere is just really full. Our atmosphere is still full of atoms, and as you go up in the atmosphere, the atoms get farther and farther
that's
apart
what
until you
I'm
go
talking
all the way
about.
out in space. Okay? So, here's what we wanted to know from today. Atoms are smaller, off the charts, incomprehensibly small, and atoms are mostly empty space. They're not too solid. And I have to draw a representation of an atom next video so for you to understand that, and then we'll build from there. Last question. What, Z?
How would atoms being arranged to form a liquid be like? How would that arrangement be different than a solid?
Okay.
Like,
That's probably good for next question. When the arrangements for like ice, when liquid water, H2O, is liquid, the atoms can go past each other. And when they're solid ice, they've linked up in actually a six-sided, like a little stop sign. I think stop signs are eight-sided. But they've actually linked up, and their electrons have tied together on the edges so that they're kind of stuck. It'd be like this basketball. If the electron 5 miles away connected to an electron 5 miles away, and then its basketball, of course, would be 10 miles away, right? And then its electrons linked together, and they locked where they wouldn't move very much, even though they are moving a little bit. That's ice. And when you heat it up enough and give enough energy that those electrons move,
Rub against
they start moving, and then they would slide it past each other, and that would turn your ice into liquid. Okay, we got to make a new video. What? This better be good. These are my two sons helping out with my chemistry video for distance.
Gas is the electrons move, the atoms move a lot faster than ice. So
Gas is just, okay, so
ice
you have
is
solid,
melting.
liquid, you have ice,
When ice
water,
is melting,
steam.
is it friction because the two atoms, are they rubbing together?
No, you're thinking you're getting the horse before the cart. It's the friction causes heat, which is energy. Heat is energy, energy is heat. All right? And so that makes the electrons not stand still, and they'll move around past each other. And so water then, just the next step of more energy, now they're even more energetic and moving around more, and they've created more space between themselves. All right? All right. I'm going to go so these are easy to move and upload. I went past 10 minutes. So hope this helps somebody. This is Chemistry Lesson 1. Thank you.